Okay, Assalamualaikum, Tajahau, and Vanakkam. My name is Luqman Hakimi bin Muhammad Zahiri, and my groupmates is Aimanul Hakim bin Azabullah and Muhammad Lufil Hadi bin Abdul Razak. We are from Group 5, 5X, BMA3. Our engineering device is a throttle valve. Okay, now we move to our objective. Okay, our objective is the first objective is the explanation of our device in terms of shape, design, mechanism, and physical features. The second objective is explain about the principle of that device and its application, and which is what is supposed to do. The third one is what happens to the fluid flowing through this device. The fourth one is how to converse the mass of our device, and uh, the second last is wrote down how to converse the energy on our device, and the last one is did our device impact on environment, economy, and human health. We have three members, so each member we explain two objective. Okay, next. The first objective is the explanation about the device in terms of shape, design, mechanism, and physical features. Here we go. Okay, our device is a throttle valve. Okay, throttle valve is a valve designed to regulate the supply of a fluid, which is steam, gas, or an air, to a system which is operated by hand wheel, a lever, or automatically by a governor. Next, and there are three types of throttle valve. For the first one is capillary tube, the second one is porous plug, and the last one is adjustable valve. And we choose the adjustable valve. On the next is, as you can see, this is a picture of the types of throttle valve. The first one is capillary tube, the second one is porous plug, and the last one is adjustable valve. Next, there are five types of adjustable valve. The first one is gate valve, the second one is globe valve, third one is ball valve, fourth one is needle valve, and the last one is butterfly valve. Alright, next. As you can see here, this is a diagram of the example of the type of adjustable valve. Okay, as you can see here, the first one is the globe, the second one is butterfly, the third one is ball, the fourth one is needle, and the last one is design of plug valve. Alright, next. From the five of the adjustable valve type of adjustable valve, we choose the ball type valve. Now we go to the ball type valve. Okay, the ball type valve consists of handle, which is this handle we use to make sure it in open position or closed position. And we have stem. Stem is the one rod that connect to the handle, and the ball which is component that block or let the fluid through it. The seat, and the last one is valve body. As you can see here is a interior design of the ball valve. Next. Okay, next we move to the second objective. The second objective is the operating principle of that device and its application, which is our device is throttle valve. Throttle valve, and we choose adjustable valve. And from the five adjustable valve, we choose the ball valve. Okay, as you can see now, this is the operation of the adjustable ball type valve. Alright, I will show you the video Enjoy.
Understanding the ball valve. This is a ball valve. Let's take a closer look at how this type of valve functions. A ball valve is used to permit flow across a pipeline. There is an inlet side and there is an outlet side. In the open position, flow is allowed across the pipeline. Closing the valve stops flow. A ball valve consists of many different parts. The main body, which houses the valve, utilizes an array of other parts in order for the valve to function properly. The apparatus that controls flow is a sphere or ball. The ball has a hole or orifice machined through its center. The stem attaches the ball to a handle. There is a slot machined into the top of the ball. The stem fits into this slot and is bolted to the handle on the other end. As you turn the handle, it turns the ball to either open or close the valve. To either open or close the valve.
Okay, that's all for me. I hope you understand about what is I explained, and thank you for lending your ears, and I hope you stay safe and stay well. That's all for me. Thank you. Assalamualaikum.
Okay, hi. Assalamualaikum. My name is Aiman Nur Hakim, and I will continue with the third question. What happened to the fluid flowing through this device? Fluid flow can be classified into two basic fluid. The first one is liquid, that is non-compressible, and the second one is gas vapor, that is compressible. As pressure change occur within a throttling valve, it is possible to produce two-phase flow at the valve outlet for either liquid or gas vapor at the inlet. And this is the end view of the ball within the valve. And this is the first state of rotation, which is where the valve is fully closed. And when the valve is fully closed, the fluid cannot flow through the ball. And we move on to the next one. The second state of rotation. The second state of rotation is when the valve is in half open. And when the valve is in half open, the fluid can pass through the ball. In second state of rotation, when the valve is in half open, the inlet will have a high pressure and low velocity. Meanwhile, at the outlet, the pressure is become low and the velocity will become high. And the final state of rotation is where the valve is fully open. And when the valve is fully open, the fluid can pass freely through the devices. For the fourth question is how to conserve the mass of your device. Higher velocity through small area. Conservation of the mass of throttling valve is about the area of the valve and velocity of the fluid. When the valve is open, the area will become smaller and the velocity will become higher. Throttling valve is operate as steady state or steady flow devices. The entering and the exiting mass flow rates are the same.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hadi bin Abdul Razak, and I will explain about the conservation of energy on throttling valve. Conservation of energy is using Bernoulli's principle, which is about the pressure and the velocity. As you can see from the equation on the left side, on the left diagram, when from the equation we can note that when the pressure is decreased, the velocity will be increased. So we can see the right diagram. When the compression spring is compressed, this compression spring is compressed, the inner pressure could be higher. The inner pressure of the throttling valve could be higher, so the velocity at the inlet will be slower. But when the compression spring is uncompressed, the outlet velocity will be higher here at this side, and then the pressure will be lower. Next, we move to the next question. Did throttle valve have any impact on environment, economy, and human health? As for environment, the throttle valve is quite eco-friendly equipment because it did not bring any harm to human and our environment. As for there is a slight problem for metal type of throttle valve because it can raise in temperature. Okay, I will explain about the raising in temperature. The temperature may increase, decrease, or constant in throttling process. It depends on the value of the Joule-Thomson coefficient. For all real gases, there is an inversion point at which sign of the Joule-Thomson coefficient changes and the corresponding temperature is called the inversion temperature. Since throttling always involves a decrease in pressure, the value of the coefficient is positive or negative, depending on whether gas cools or warms up after expansion. From the graph, from this graph, we can see if the gas after throttling lies within the inversion curve, its temperature decrease. If outside, then the temperature increase. For ideal gases, the value of the coefficient is 0 since enthalpy is a function of only temperature and thus dt is 0. So, ideal gases, neither warm nor cool, is down during throttling process. For hydrogen and helium, the Joule-Thomson coefficient is negative, whereas when the hydrogen and helium is warm up. For oxygen and nitrogen, its value is positive when there is cool down. Next is for the economy. I think it's quite a high demand for the economy because the throttle bar is quite eco-friendly and it's quite cheap in the market. So it's very high demand from the customer. As for the human health, I cannot find any accident happen involving the throttle valve and the human. So I can say it quite safe for the human to use throttle valve. That's all from me. Thank you.